All right, y'all, let's get started. So today is a new topic in Algebra 2. Yay, new topic. We're doing factoring polynomials by grouping. So go ahead and make sure you write down the notes title, 1.2 notes, factoring polynomials by grouping. And then we're going to start with this little think about it prompt. So I want you to think about this question. You're going to answer a question in a second about this. Is x squared times x plus 5 plus 4 times x plus 5 the same as x squared plus 4 times x plus 5? Explain why or why not. Okay, so what I want you to be thinking about right now is what method, what action could you take to answer this question? What could you potentially do to see, are these two the same? What could you do to check if those two are the same? Okay, so I'm not sure, like you could do a variety of things. You could actually try multiplying this, and you could try multiplying this out, and you would get the same thing. These actually are the same. These two things are the same, but I want to show you another method, just in case you didn't say multiplying. So let's think of a different method. I'm going to erase that. They are the same. But here's what I want you to think about. What do we notice about this first equation, or this first expression? They both terms in this expression have x plus 5 in it. What do we call something that both pieces have in common that is being multiplied in both pieces? Go ahead in the box, tell me, what do we call it when you have something in common? What would we call this x plus 5 factor? Go. Okay, so this is actually the GCF. GCF is x plus 5. It's that factor. So let's try taking out the GCF now. So if we take out the GCF, we put it out in front, we're going to have x plus 5 out in front, and then we put our parentheses, times, and we write what's left. When we divide by x plus 5, what's left? X squared is left on the first piece, and 4 is left on the second piece. So check it out. These two are the same. All right, today we're going to learn how to factor an expression. This expression can also be written as this, equals, if you multiplied everything out, you would get x cubed plus 5x plus 4x plus 20. These are all the same things. They're all the same. All of the expressions that we started with. So this, whoa, sorry. I meant to get my pink marker. Okay, there we go. So this, and this, they're all the same thing. Okay, so now we're going to learn how to start here, how to start with the long expression with 4 pieces, 1, 2, 3, 4, and how to get it into 2 factored pieces, how to get it to here, 2 pieces that are fully factored. Okay, here we go. So go ahead and make sure that you get the example down. Factor by grouping. We're going to go through an example and some steps, and then you're going to try on your own. Okay, so you should be writing this example down. Cool. So really quick, what's the first step that we should always check for when we're factoring? What's the first thing we should always look for? Let's call this step 0. Step 0, what should we always look for? A GCF. So before you start factoring anything, you should always look for a GCF. So look for GCF first. Cool. Now let's move on and let's learn how to do factor by grouping. So actually, let's look for our GCF. Is there anything in common in all 4 pieces of these? Can they be divided by the same number? These can be divided by 2, but then 5 can't be divided by 2. So no, there's no number. They don't all have x's. So there is no GCF. Okay, so we finished like step 0, which is look for GCF. Now let's move on to the next step, which is going to be group. This is called factor by grouping because we're going to start with group. And then I want you to do put parentheses around first 2 and last 2 terms. Okay, so I'm going to do this first step up on our problem up top. So when I say group, I want to put parentheses around the first two terms. So the 64x cubed is the first term, 80x squared is the second term. So I'm going to put parentheses around those two. And then I'm going to put parentheses around the last two terms. And I'm actually going to leave this negative out. So I'm just going to take the 4x plus 5. Okay, so you should be putting parentheses around your first two terms. Now let's go to the next step. Step 2 is to take, oops, I don't know why I spelled take wrong. Take a GCF just out of the first group. Take a GCF just out of the first group. Okay, that's the first group of parentheses. So we're going to be looking in this group, and we're going to take a GCF out. So what can divide into both 64 and 80? These are big numbers. I'm going to let y'all know. The GCF is 16. 16 can go into both 64 and 80. And how many x's do they have in common? You remember when you're taking a GCF, you take the smallest number of x's away. So you're going to take 2, because this has 64 has x cubed, and 80 has x squared. You're going to have to take just the smallest number of x's away. Cool. And now we're going to write what's left, because that's part of taking the GCF out. So let me write what's left. We have 64 divided by 16 is 4x. Copy my minus sign down. Oh, sorry. We took 2 x's away, right? There were 3 x's here. We took 2 out, so there's 1 x left. But we don't need the 1, right? Whenever the exponent's 1, we don't need that. So now, what do we have left on the next term? 80 divided by 16 is 5. And we started with 2 x's, but we took 2 x's out, so we have no x's left. There's no x's left. Okay, now that we have done that, we are going to, the next step is to then copy. So what I'm going to write down under here as part of step 2, we're still on step 2, and I'm going to do this in a different color. Then, scroll down a little bit, then copy what is left inside your parentheses. Now, you can think of this as two things. You can think of it as taking another GCF out, so I'm going to show you both ways, or you can think of it as copying. So really quick, if I took a GCF out of this, what do 4 and 5 have in common? Just, they can both be divided by what number? 1. So we're going to think of always bring down your sign, minus, and then you're taking the other GCF out. When you do that, what's left? 4 divided by 1 is 4. We still have the x. And then this is the tricky part. 5 divided by 1 is 5, right? But this negative, we're taking negative 1 out. So this is going to turn into a minus sign. And the reason why is you need to always check yourself when you take out a GCF. So like, let's do a quick check. Remember how to check. If you multiply this in, you should end up with the same thing you started with. So let's try that. You get negative 4x, and negative times a negative gives me positive 5. That's what we started with, right? So we did take the correct GCF out. Okay. So the reason I said you could think of it as copying is because look at what we had for our first set of parentheses. Right here, we have the same, if you're factoring by grouping and it's working, you should always get the same thing in your 2 sets of parentheses. Okay, let's move on. So now we're on step 3. And I'm going to write it and then like scroll back up. So step 3 is combine. I'll do that in pink. combine. Step 3 is combine the outsides and take only one of the parentheses. Oops, parentheses. Oh man, I can't spell. Okay, parentheses. Okay, so combine the outsides and take only one of the parentheses. Or like copy. We could say copy one of the parentheses. So what do I mean? Get that down in your steps, and then I'll show you what I mean. Cool. Combine the outsides. Okay, 6x squared and -1 are on the outsides here, so we're going to combine those. 16x squared minus 1. Combine the outsides. Cool. And then our step said copy only one of the parentheses. So we're just going to copy one of these 4x minus 5s. Sweet. Y'all, we just factored by grouping. We took something that had 4 pieces, 1, 2, 3, 4, and we factored it into 2 factors, 2 groups. Okay, so the last step is to see step 4. Let's write this final step down and then do it. Check if you can factor any more. If you can factor any more, and then solve. Okay, check if you can factor any more, and you can say like, look inside parentheses. We're going to look inside the parentheses to see if we can factor anything else. And then we're going to solve or find the solutions, find x. Okay, let's do that now. See if we can factor any more. Can we factor 16x squared minus 1? The answer is yes. Hopefully you notice that we can factor that. What method, what trick do we use? Difference of squares. We can factor that using difference of squares. You could take the square root of 16. Square root of 16 is 4. Square root of x squared is x. Square root of 1 is 1. And then remember, anytime you use difference of squares, you have to get a second factor that has the exact same thing except a flip sign. So that 16x squared minus 1 turns into 2 pieces. And then can we factor the 4x minus 5 anymore? No, we cannot. There's nothing we can do here. So that just stays 4x minus 5. Here are all of our factors. So please make a note. These are your factors. Factors are in parentheses. They're separated by multiplication. A lot of us are struggling with the difference between factors and solutions. These are factors. Okay, now we need to solve. Find the solutions. I'm going to do that in the last color, which will be magenta. Okay, so let's solve. What does x equal? That's what solving means. So x equals, for this factor, I'm going to use my trick. X equals, flip the sign on this number. So positive 1 over, divide by this number, 4. And let's do the same thing for this factor, negative 1 over 4. And let's do the same thing for this factor, positive 5 over 4. Okay, so factors, and then make a note. These things are solutions. So when your test is asking for solutions, that is a different thing than when it asks for factors. Sweet. Now we're going to try a practice problem. So hopefully you got all of those notes. I'm going to zoom out and make sure that you have all the steps. Group, put parentheses around the first and last two terms. Take a GCF out of the first group, then copy what's left inside your parentheses. And y'all, the second step is a little vague. People like to think of it different ways. So I'll help you on the practice. We'll see if we can get the hang of it. This is a really weird kind of factoring, but we can do this. Okay, let's try a practice. So I want you to write down this practice problem. And I will leave this example up while you practice. So You should have the steps in your notes, but I'll leave the example up. Okay, so here we go. Write the practice problem down. We have g of x equals x cubed plus 3x squared minus 4x minus 12. This is your practice problem. And I want you to try each step. So, first step we did in purple. I will go ahead and do that for us because that's kind of hard. Actually, well, yeah, that's kind of hard to represent in the box. So first step is put parentheses around the first and the last term. Ooh, y'all, by the way, put a little star. Little star. You have to start with standard form. So what do I mean by that? You have to start with standard form. What I mean is you should have the largest exponent first. X cubed comes first, then x squared, then x, then your number. Which this is already in standard form, so this is ready to go. But sometimes you won't have the problem given in standard form. So you might want to move some things around to make sure it starts in standard form. Okay, so first step, put parentheses around your first two terms and your last two terms. And then we can go to step 2. Step 2 was in orange. It was factor out the GCF on this first set of terms. So in the box, I want you to tell me what is the GCF on the first set of parentheses. Go. Okay, hopefully you said the GCF was x squared. And then I want you to now take a second to write what is left. What's left when you take out an x squared? Should be doing this on your paper. And now check yourself. Did you get x plus 3? That's what you should have gotten. Okay, cool. My next step says to copy what is in this set of parentheses. So we're just going to leave a space and copy x plus 3. Leave a space and copy x plus 3. And I'm going to bring down my minus sign. Minus. Okay, so this is how I like to think of this one. You can think of it two ways. You can think of it, what is the GCF between 4 and 12? Or you can think of it as, what number needs to go here so that when you multiply it in, you get 4x, because you have to get back to what you started with, 4x and plus 12. So the GCF between 4 and 12, GCF is 4. That's what goes here. And if you multiply the 4 in, you'll get 4x plus 12. That's how I know that that is correct. And, oh, sorry, if you multiply the negative 4 in, right? We brought down the negative sign. So if you multiply negative 4 in, you get negative 4x minus 12, which is what we started with. You have to be able to get back to what you started with when you multiply that number in. Okay, cool. Let's move on. So third step. Third step was combine the outsides. We did that in pink. And bring down one of the parentheses. Okay, so now combine the outsides. Go ahead and do that on your paper and bring down one of the parentheses. And it should look like this. X squared minus 4. We combined the outsides. And now we're going to copy one of the parentheses. X plus 3. Sweet. Our next step that we did in green was check. Can you factor anything else? Can we factor anything else? Can we factor x squared minus 4? Can we factor x plus 3? I want you to tell me in the chat, can you factor one of these? And if so, what should you write as your factors? Go. All right, so we can factor the x squared minus 4 with difference of squares again. What do you know? So difference of squares, that's going to turn into x minus 2, because the square root of 4 is 2. And then you have to copy that because we use difference of squares, x plus 2. And then don't forget to bring down your x plus 3 factor. And now we have all of our factors. Yay! And you should be able to tell me what are your solutions, what is x equal from these factors. So very quickly on your paper, tell me what does x equal? X equals 2, -2, flip the signs, and -3, and we're done. That's it. All right, let's get some more practice in.